Welcome back to CTN. Let's get started with CoreMotion. Sensors: an accelerometer, a gyro, and a magnetometer. The accelerometer measures units of gravitational acceleration in an X, Y, and Z axis. A gyro measures rotation in radians per second, and a magnetometer measures magnetic field microteslers in the X, Y, and Z plane. Now, not all devices have all three. Everyone has an accelerometer. That's how rotation of applications is detected. Not all of them have gyros and magnetometers. There's a fourth item, which is referred to as device motion, which uses an algorithm to do error correction on data, sort of integrating data from all three devices or three sensors. Now, I'm going to show you a demo of an application, but just as a note, there's a slight misspeak in the first demo. The x-axis runs across the screen from left to right when the device is in portrait mode. Let's go to the demo. What you are looking at is a QuickTime screen recording of my iPhone SE. The purpose of the application is to explore the data that comes out of CoreMotion. I'll be going over the design of the application and its code in the next part of this two-part video. What is displayed here is data coming from the accelerometer and data coming from the gyro. Now, for now, what I'm going to do is I'm going to turn off the gyro data so that it doesn't distract from the first part of this discussion. I'm going to lay the device, the iPhone, down on my desk, and what you should think about is the z-axis being left and right across the screen, and the y-axis being vertical. The z-axis is perpendicular to the screen. Now you see these numbers change, and I'll have to describe to you as I do things what the motion of the device is. Obviously you're not seeing that, you're only seeing the screen. What is shown in acceleration is a gravity vector. There's a negative gravity vector in the z-axis. So in other words, it's down perpendicular to the screen. Now, if I turn the device over, z is now 1. Now the little comment below the numbers is 1g equals 9.8 meters per second squared. That's the actual acceleration of 1g. If I pick the device up and I turn it on its left side, I get a minus 1x. If I turn it over, plus. Similarly, if I turned it upside down so that it's sitting on its top, I get 1. Now let's turn on the gyro, or the gyro data. Now what is being shown here is angle of rotation, and the device is laying on its back again. A little bit of jittery at 1 degree. What I'm going to do is I'm going to rotate the device on the z-axis. Now you notice this rotation, and this is in degrees, so I've rotated it minus 49 degrees. You notice there's been no change in the accelerometer. The gravity vectors are the same. They have not changed. but the gyro is reporting rotation. Now what it's actually reporting is change or speed of the rotation. In other words, radians per second. And there's 2 pi radians in a circle. The application integrates that data. In other words, it takes the velocity of the rotation, which is what's being received, and sums it or integrates it to an angle and converts it from radians to degrees. Now if I pick the device up, you'll see all kinds of activity. I'm going to rotate it around the z-axis. Rotate it primarily around the x-axis. Now you'll see the other ones change too because holding it is not perfect. And so on. I'll lay it down again. Now if I reset gyro data, what that does is reset the angle to 0. Because in an integration, it's always relative to where you start from. So I could pick it up and start rotating the device again. Let's go to the next part of the demo. Okay, I'd like to continue the demo with a little bit of an experiment here. I have the iPhone turned upside down against a horizontal and vertical surface. Now you'll notice that the Y component is 1. There's been a little bit of jitter in the rotation since I started the application and the recording. What I want to do is I want to rotate the iPhone against its one corner till I hit a z-axis of 45 degrees. Rotation around the z-axis. Okay, you'll notice that I can tune this such that 0.7, 0.7, and I get an angle of 45 degrees. So I've rotated 45 degrees, and I now have a 45 degree angle indicated on the X and Y component. Okay, I'd stay tuned to part 2, and we'll talk about the design of the application.